Okay, let's look at this calculus practice exam. Find the equation of the tangent to this curve at the point where x is 2. So equation of a tangent, if we have any curve and we get the derivative, that will find the slope or gradient of the tangent anywhere along it. So we have a tangent at x equals 2. So if we have something like this, x equals 2, we're looking for the equation of that tangent. Now, equation of the tangent, I like to use this formula. Okay, that's for the gradient, and we have a point x1, y1. Okay, so at the moment, we don't have a gradient, and we only have half a point, because where x is 2, that's like 2, and we don't know the y value. Okay, so let's find the gradient function, which is the derivative of this, which we will use a little bit of chain rule. E to the 2x minus 4, and then that would be multiplied by the derivative of the exponent here. So that's derivative of 2x minus 4 is just 2, and then the derivative of x is just 1. We tie that up, maybe bring the 2 in front, and we have this as our first derivative. Now at the point x is equal to 2, if I put that in for x here, that will get the slope of this, the gradient of this line, which is my m here. So I'll do that. Substitute in 2. So that's 2 e to the 2 times 2 minus 4 minus 1. This is 0, 4 minus 4. So 2 e to the power 0 is 1. And we will, anything to the power 0 is 1. So 2 times 1 is 2. 2 take away 1 is 1. So we get a slope of 1. So the gradient is 1. That's very convenient. We just need to find the x value or the y value to go along with this x value. How do I do that? Well, the only thing that says y equals is here. So if I substitute into that as well at x equals 2, I will find where y is equal to, what y is equal to at that point. So e 2 times 2 minus 4 minus 2 this time. So x is 2. Oh, x is 2. That's still 0, so that's 1 take away 2, and that's minus 1. Remember, e to the power 0 is 1. So that's minus 1. So I've completed my point, 2 minus 1. And now I'll use this formula finally. y1 is minus 1, so that's minus minus 1, which is plus 1. The slope is 1, or gradient is 1. X minus x1 is 2. So this is x1. Okay, we can multiply this out a bit. 1 times that is just what it is. And maybe subtract 1 from both sides, and we get this as our answer. Okay, next one, so that's what an equation of the line looks like. It should have an x and y in it. This one, find the first derivative. Okay, I will. Before I do that, I will rewrite it a bit. So that'll be x cubed minus px minus 1. So x down here in the denominator can be written x to the power minus 1, which will help us with our derivative. Multiply down by the 3, subtract 1 from the power. Multiply down by the old power, so that's plus p minus 1 times minus p, and subtract 1 gives minus 2 here. And a rewrite of this gives p over x squared, so that can come back down a negative power in the denominator. So that's a. B, there is a minimum value of the function when x equal to 1. So if I minimum value, anytime I see minimum, I know that the first derivative equals 0, because at a minimum point, the gradient of the tangent there is 0. It's a flat line. So I will let the derivative, which I've just found, that's the derivative, I'll let it equal to 0, and then it says at x equals 1 that happens. So at x equal to 1, that happens. So I'll substitute in 1 here. A convenient substitution. That's 3 plus p is equal to 0. So p has got to be negative 3. And that's it. Okay, so question 3 on this one. Come on now. Question 3. We have this function. Fx is 4x sine 2x. Okay, so this has a little look of a product rule here. There's a function and a function multiplied together. So let's use the product rule. So we're going to use the product rule, which is going to be the first by the derivative of the second, second by the derivative of the first. So 4x times the derivative of this. Then what is the derivative of that? It's going to be cosine 2x, but we have only derived the sine part. We need to derive the inside part, which is times by 2. That's the derivative of the 2x. Plus, and we derive the second part then, which is just 4. So the derivative of this function, 4 times, and whatever this was already. Okay. I then would multiply out anything I can. So I have 8x here from the 2 times 4, cosine 2x plus 4 sine 2x. And that's as much as I need to do. So that's the first derivative. Perhaps you can tidy that up a little bit, but I won't, because I'm going to do part B first. Find the gradient. So gradient again of a curve. So gradient of a curve. This is the gradient function. All I need to do is sub in pi over 2 into it. So f with pi over 2 put in is 8 times pi over 2 times cosine 2 times pi over 2. So I'm substituting in for these x's, plus 4 times sine 2 times pi over 2. Okay, tidy this up. 8, 2 divides into 8 4 times, so I'm left with 4 pi here. This is cosine pi, 2 times pi over 2, plus 4 times sine pi. Okay, now I need to know my unit circle to finish this off. What is cosine pi? Well, where's pi on my unit circle? It is all the way around to here, right on the x-axis. That point, because it's a unit circle, is minus 1 on x and 0 on y. And this is the angle pi. So we should know that cosine and sine are the x and y axis. So cosine of pi, we just found, all the way around here, is at this point minus 1. So 4 pi times minus 1, and 4 sine of pi is 0. So my answer is negative 4 pi from this, and 4 times 0 is just 0. Okay, next question. 4. Consider this function, tangent again, tangent to a curve, find the equation. Okay, so this is my function, 5x squared minus 6x plus 7. I'm going to derive it first. Multiply down by the whole power, 2 times 5 to give 10. Subtract 1 from the power. This is just goes to 6, and the 7, the constant disappears. So this is my gradient. If the gradient, all right, so sorry, the line is tangent to the curve at point P. So we got some sort of U-shaped thing. We got something at the point P. This is the point P. I know the gradient of this line is 4. So the slope or gradient of this line is 4. So I know the answer to this is 4. What is the coordinates that give 4? So the slope is 4. What coordinate gives 4? What x value here in the P point gives 4? So I'll try and solve this. I think if I add 6 over to this side, I get 10, so x is 1. Okay, if x is 1, I need the coordinate. I have only half the coordinate now. I need to find the y. So the only thing that gives me y is this original function. So 5 times, so y will equal 5 times 1 squared minus 6 times 1 plus 7. Y is then, so this is going to be 5 minus 6 plus 7. Y then is equal to, what's that, 12, 6 is it? I think. So that's 6. Okay, that's the first thing. And then we need to find the equation of the line. So that's going to be quite straightforward because we can use this formula. We already have a point, 1, 6. We're given the slope in the question. It was 4, the gradient is 4. So I'm going to use both these things and put it into this formula to get me an equation of a line. So y minus 6 from y1 is 4 times x minus 1. Multiply that out. Rearrange so it's y equals. Maybe it's a good thing to tidy up so we don't have 2 constants in it. Get it down to 1. Add 6 over here. And that's the equation of the line. All right, next one. We are looking at a looks like a natural log and 6x together. So we're trying to combine these two, find the first derivative and the second derivative. Okay. So let's find the first derivative first. We have 6x minus natural log x. So the first derivative is, the derivative of 6x is okay, it's just 6. What's the derivative of ln x? I think it's one of our special derivatives, isn't it? It's 1 over x. We looked at that one before. Okay, so that's the first derivative. Don't need to do anything with that. So that's A. Part B, find the second derivative. So derive that derivative. So 6 derives to nothing, so I won't write that. Perhaps a little rewrite here. That's the equivalent to that. It just helps me with the powers here. Minus 1 times this minus in front gives plus 1, so it's going to be plus x. Subtract 1 from the power, brings me down to minus 2. And I rewrite here as 1 over x squared is the derivative of that. Part C then, it says, solve them equal to each other. Where are the derivatives equal to each other? So I let them equal to each other. This was the first derivative, 6 minus 1 over x. This is the second derivative, 1 over x squared. How do I solve something like this? Well, I see a quadratic in my future because I've got x squareds, x is in a constant, but it's normally not written like this. So I will get a common denominator of x squared or multiply everything by x squared. If I multiply this by x squared, multiply this by x squared, and multiply this by x squared, what happens? This one just becomes 6x squared. This one is x squared divided by x, which is just x, and the minus is still there. So x squared divided by x is just x. And what about x squared divided by x squared? Well, they're just going to nullify themselves, and they're going to equal 1. Bring everything over to one side. We can attempt to factorize here. You can use the quadratic formula if you like. So 3x and 2x. I'm splitting up the 6. I need to know it's split up because if I leave 6, I'm never going to get 1 in the middle here. Factors of 1 are 1 and 1. Now, what way will this work? So I do my little test here. 1 times 2x is 2x. 1 times 3x is 3x. I need to make a negative x. So if I make that negative and that positive, I think I make a negative x. So that negative and that's positive. I do. Okay. Finish off then. 3x plus 1 is equal to 0 and 2x minus 1 is equal to 0. X then is equal to minus 1 divided by 3, and x is equal to positive 1 divided by 2. Then I have a little look. I have 2 solutions here. Are they both okay? I do look at my question again. It says for x greater than 0, which is got to do with this ln x. So x has to be greater than 0, so only one of these answers I will accept, because x has to be greater than 0 from the question. Question 6. So consider this function. X cannot be minus 1, so they put that in there because it's an asymptote, because if x is minus 1, this would be dividing by 0. So if I do get an answer somewhere where x is minus 1, I ignore it. Find the value of p for which the graph has exactly 1 point with a gradient of 0. Okay, so gradient is involved in this. So first of all, I'm just going to get the derivative, recognizing that this is quotient rule, which has the denominator multiplied by the derivative of the numerator, which is going to be 8x plus p. So 2 times 4 to give 8, and then this x will disappear. Minus the top, which is 4x squared plus px, times the derivative of the denominator, which is just 1, which is 1x, all over the denominator squared. Okay, I'm going to tidy up the numerator, just multiply everything by everything here in the numerator. X times both these gives 8x squared plus px. 1 times both these gives some, make sure I multiply everything by everything else. 8x plus p, and then subtract this multiplied by 4x squared minus px, all over x plus 1 squared. So that's my derivative. I can tidy it up a little bit. I'll just look at what the question asks next. The value of p for which the graph is exactly 1 point with a gradient of 0. So the gradient is 0, so this will equal 0. This equals 0. I multiply both sides by this. And this will cancel with this, and this goes to 0. So multiplying anything by 0 goes to 0. Okay, so I'll tidy this up and see what I got. So I've used the where gradient is 0. I haven't used the exactly 1 point yet. Let's tidy it up. 8x squared minus 4x squared is 4x squared. The px and the minus px cancel. I got an 8x and I got a plus p equals 0. Okay, now I'll use the exactly 1 point. If I ever see exactly 1 point, one solution to a quadratic equation, that means I will use the discriminant, because the discriminant will have to equal 0. And that's what I know, because otherwise it will give 2 or 0 solutions. So if the discriminant is 0 of this, remember a, b, c, I should be able to find what p is, because the discriminant does not have x in it. So 8 squared minus 4 times 4, because a is 4, and c is p is equal to 0. So I have 64 minus 16p is equal to 0. If I rearrange that a little bit, add the 16p over this side, and then divide by 16, I think that p equals 4. Okay, and we're on to the last question, which was a binomial mixed in. Okay, so we have a binomial, just what you wanted to see. We have fx is equal to x squared plus a to the power of 5. In the expansion of the derivative, f-1, the coefficient of the x5 term is 960. Find the possible values of a. Okay, so in the expansion of the derivative, so let's get the derivative first. So this is going to be chain rule, 5x squared plus a to the power of 4. So multiply down by 5, subtract 1 from the power, and don't forget to multiply by the derivative afterwards, the derivative of the inside. The derivative inside is just going to be 2x. What happens to the a? Well, the a is just a number. So if it's 5, it would disappear in the derivative. So this would be our derivative. Let's tidy that up a little bit. We get 10x x squared plus a to the power of 4. Okay. We know the coefficient of the x5 term is 960. So 960 x5 is in this expansion. Which term is it in the expansion? Well, that's what I need to figure out. I know that each term in the expansion, so I'm talking about the expansion of this. This is the binomial bit. Each term in the expansion is going to be multiplied by 10x. So I'm actually, out of the expansion, I will be looking for the x4 term, because x4 times x gives x5. So I'm looking for the x4 term in this expansion. So which term is going to give x4? Well, I'll go to my general term for binomials, which you may have forgotten. Power 4 was here. So which power gives x4 out of this? Well, this has to be 2. And this has to be 2, because that's x squared squared is x4, which means this has to be 2. And all that is going to be times by 10x. Now there's loads of terms here. Now you could expand this whole thing as well. That would take a while. But I'm only looking for one term from it, so I might as well just find that one term. When I input this into my calculator, it gives me a 6 NCR. You can draw your Pascal's triangle if you're not sure. And I have 10x times 6 times x4 from this, and this is a squared. That equals 960 x5. Now, x5 is going to cancel with that and that, because that is x5. So I'm going to be left with 60, 6 times a squared is equal to 960. So what does a equal? A squared is equal to 960 over 60, and it's actually equal to the square root of that, 960 over 60, which I can do on my calculator, which I've done already. So just type it into your calculator, and I get 4. Now we get, it should be plus or minus 4 here. A can be plus or minus 4, and there's a hint here in the question, possible values of a, so I needed 2 values. Okay, and that is all the answer.